Good morning. Uh, Today we are going to uh, discuss on hypothesis testing, which is reading 11 in CFA level 1. So we are going to see how to accept or reject the null hypothesis, and how to calculate the test statistic for coming to a conclusion to accept or reject the null hypothesis, and what are the various tests available for samples to accept a null hypothesis. So we'll go through all of them one by one. So hypothesis testing is an important tool, an important quantitative tool in investments, and it's very easy to understand as well. So basically, you have a null hypothesis, H naught, and an alternative hypothesis, which is known as HA. So the notation is H naught and HA. A hypothesis is a statement about one or more populations. So now we can have one-sided hypothesis or a two-sided hypothesis. If we say, for example, H naught, if the H naught, the null hypothesis say theta equals a particular value, theta naught, the alternative hypothesis will be theta naught equal to theta naught. So it means theta can be greater or less. So this is a two-sided hypothesis. Whereas if you have a hypothesis like this, theta less than equal to a particular value, theta naught, then alternative is theta should be greater than theta naught. This is a one-sided hypothesis. Likewise, you can have another one like this. Okay, so this is the one. So always remember, null hypothesis H naught is the hypothesis to be tested, while the alternative hypothesis is the hypothesis accepted when the null hypothesis is rejected. Okay. Now, how do we come to a conclusion whether to accept the null hypothesis or reject it? So first we need to know what is a test statistic. We need to compute a test statistic for a sample, and then this has to be compared to a critical point or a rejection point. So based on that, we in a distribution we will come to the whether to accept or to reject the null hypothesis. So test statistic, I will write it as TS, test statistic, is equal to sample. You are looking obviously from a sample statistic minus value of population. So you know, sample is a subset of a population parameter. Usually the mean mu under the null hypothesis, not the alternate hypothesis, divided by SC, standard error of the sample statistics. Okay, so this, if you write it symbolically, test statistics is equal to x bar minus mu naught divided by s divided by square root n. So s is the sample standard deviation, mu naught is the mean of the population, and x bar is the sample statistic, and this is known as the standing. This is known as the standard error. Standard error. N is the number of is the size of the n is the size of the sample. Size of the sample. So depending on the sample, how we are doing, we have there are 4 tests: a t test, a z test or a standard normal test, chi-square, and f test. So we have 4 tests available. A t test, okay, and I will come to like under what conditions use a particular test. Then we have a z test, is for a standard normal distribution. If it's standard normal, you can use a t test or a z test. If the distribution is standard normal, means it can be completely described by 2 parameters: mean and standard deviation. Standard normal like n, mean, sigma. Or you have the chi-square. This is a simple this is called chi-square test. So these come under when there are 2 samples. These are single sample, and also you have the f test. These are the 4 tests available to determine the hypothesis, okay, the acceptance or rejection. Now there are of course type 1 error and type 2 error in hypothesis, which is what we need to know how errors can happen. Suppose the given hypothesis, null hypothesis, is true, or it can be null hypothesis can be false. This is the actual thing, but the analyst has made a decision which can be right or wrong. So what is the type? Okay, now the decision of the analyst not reject H naught, reject H naught. So this is the objective of the hypothesis. So he not reject H naught. So when H naught is true and he or she does not reject H naught, this is a correct decision. This is a correct decision. Even if H naught is false and he does not reject it, H naught is false and he does not reject, means he accepts H naught. This is a type 2 error. And he rejects H naught when H naught is true. This is a type 1 error. And rejects H naught when H naught is false. This is a correct decision. So you should be remember this one, because this will come very important. So what is a type 1 error and what is a type 2 error? When you reject H naught when H naught is true, it is a type 1 error, and not reject H naught when H naught is false is a type 2 error. Okay, now let me show as a distribution what suppose we have a two-sided test, a bell curve, two-sided test, and we have the origin or the mean here. This is a, looks like this is a standard normal curve. So mean is 0 and variance is 1. Mean is 0. So minus 1. This is 2 standard deviations. Plus, okay. So 95% of the area is under this one. Okay, this is 2.5%. Well, the test statistic is less than minus 9.6. So yes is less than minus 1.96, which is actually 2 sigma, and approximately 2 sigma. And this is this area is TS is greater than 1.96. 0.025, not 0.25. It's 2.5% is the probability of this of the test statistic being greater than 1.96 or less than minus 1.96. So this is the acceptance. So if the test statistic lies in this region, 95% acceptance region, and this is the rejection region, beyond one rejection. This is a two-sided test, so you will have on both sides. This is a rejection region. So when you calculate the test statistic, if it lies between minus 1.96 and plus 1.96, you accept, and then more than you reject. This is called alpha. This is called the level of significance. This is called level of significance, alpha. If the calculated value of the test statistic is more extreme, the positive side, negative side, than a given value or values determined by the specific level of significance. So if it is a 5%, this is a two-tailed test, so 2.5 plus to 5%, 5%, we reject the null hypothesis. The result is statistically significant. Okay, thank you.